everyone, this is Group 555 and very glad to be here and share with you guys about the findings of our project. Since we're all very familiar with the background and objective here, so I just want to skip it and mainly share with you guys about the logics, about how we are going to handle these two problems. As for the new cases, actually, we didn't find a very good indicators that will help to predict. So we just use a single time series. And therefore, it's very important that we can choose the right sample period and we can very carefully deal with the data. As for the unemployment rate, actually, there are so many mature economic series. So we try to use the VAR model to explore the interactions between these factors. And it's very important that we can choose the right variable. And also, a ARIMA model will be used to compare the performances between models. So let's first start with the new case prediction for Singapore. If you look at the data, you'll find the new cases were quite stable and low for a long time, although things changed during this period. Anyway, we just use this single time series and our sample starts from here, which is the first peak, so that all the data after that, we can assure that government actions have taken effect. And then we use the differences of logarithm to draw the ACF, PACF to help us decide on the model, and Arch1 we used to fit the heteroscedasticity. And finally, we got the model ARIMA 017 and Arch1. These analyses guarantee the sufficiency of using this model, and then we can get our prediction. And let me first explain about the internet here. This is because we calculated the MAPE based on daily data, and there were zeros in August. Anyway, when you compare the true value against the predicted value, we find that at the very beginning, the performance was quite good. But as time passed by, the model gradually failed to catch up with the growing speed. We believe this is probably because the government was trying to recover to normal life. So probably data characteristic changed while the parameters of model were fixed.
Well, let's look at the new cases in the UK. The number of COVID-19 new cases in the United Kingdom has changed dramatically over time, while the indices are quite stable. So we just use new cases in the past to predict the future new cases. To obtain stationary time series, we use log of new cases plus 1 series, then make a first order difference. For 2 days, the number of new cases are negative. So in order to take the logarithm, considering these two values to be 0. For data integrity, training data set starts from 2020, January 1st. Next part is model selection. The ACF is significant when the lag is 1, and the PACF decays towards 0. So we choose a ARIMA 112 model. And the ACF of residuals and the square of residuals shows that there is no arch effect. Final part is the prediction. From the prediction, although the model is quite simple, the red lines fits well with the blue one, and the MAPE in October is only 0.1, no larger than the MAPE in validation period.
Next is about the US prediction. We first look at the data. Most properties are similar to the previous ones. The only difference to show is that the data shows a severe vibration. The ups and downs show that there may be some seasonality here. The decomposition shows that there exists the seasonality with a period of 7 days. In fact, research indicates the new cases for most countries has a periodicity of weeks. This phenomenon may be related to the testing capacity of the institutions. Therefore, we use the S-ARIMA model here. The selection of PDQ conforms to the principle of minimal BIC, and the residues show the arch effect. After fitted in the arch model with t-distribution, the final residues are well scattered. Finally, we use the hybrid S-ARIMA plus arch model to fit and predict. The precision of validation period is perfect, but the test period does not meet the expectation. The reason may be the 31-step forecast is too long, where unfortunately, the trend is not the same as the previous several days.
When it comes to prediction of unemployment rate, the original data amount is too small and we extend the data to 2011. From the graph, unemployment rates of the 3 countries rose sharply in 2020, with the US region being first. After the first order difference, All of the three series are stationary. From CCM of the three different series, we can start the VR model. However, the prediction of VR model is not so accurate for some data, which we will see later. Then we can start to focus Singapore's unemployment rate separately and add two new variables, GDP and inflation rate, according to Okun's law and Phillips curve, respectively. After the first order difference, all of the three series are stationary. From CCM of the three different series, we can start the VR model and get VR12. The residues have similar features to white noise with no serial correlations and meanwhile insignificantly lack cross-dependence. The model is adequate. To compare the predictions, we also consider a RIMA model for unemployment rate. From ACF and PACF of the series, we can start a RIMA 110. There is no autocorrelations for residues and no gauge effect. Then we use this model to predict. Therefore, there are three models for prediction, and the first model has the best prediction.
The UK unemployment rate has been on a downward trend until January 2020, and the impact of COVID-19 has led to a rise in it and a sharp decline in GDP. First, based on Okun's law and Phillips curve, the unemployment rate, the GDP, and the inflation rate have interaction, and this is also proved by the CCM of them. Besides, all the three are stationary after first-order differencing, so a VAR3 model was established. And the right-hand side gives further analysis which guarantee the sufficiency of VAR3. After that, to compare the predictions, the single time series of unemployment rate is also used to build a RIMA 1-to-1 and Ultra-1 model, which is proved also to be sufficient. And here shows the one-step forecast results. Comparing the three models, the Armour-Gauge model, which is the red line, provides the best prediction, which is shown as follows. And for the United States, the unemployment rate showed a steady decline before March 2020, and after the epidemic hit, it increased sharply, while the GDP also decreased sharply. And same as before, based on Okun's law and Phillips curve, the VAR model of the three factors is established. And what is different here is that the auto-RIMA function result of the single time series of unemployment rate shows that the fittest model is a RIMA 0-1-0, which lacks practical significance and is therefore abandoned. The CCM among the three factors shows that the interaction exists, and these three factors are also stationary after first-order differencing. So a VAR3 model is built successfully, and the model is proved to be sufficient also. At last, we performed prediction and made comparison between the models, and the VAR3 model of US, which is the red line, gives the best prediction, as shown here.
So to summarize our prediction, for each data, we used customized models and training data. For the new case prediction, we only use the data itself to construct the model. We all apply the hybrid ARIMA plus Gauge model with variant adjustment. For the unemployment prediction, we apply the VAR cross countries, ARIMA model, and VAR model with GDP, respectively. The prediction result is robust during the validation period, and for the test period, the unemployment rate still performs good. The new cases prediction has some deviation from the true value due to the long steps forecast. To conclude our prediction methods, there are some good points. First, the models are simple and have clear explanation. Second, the choose for length of the training data are flexible according to the external variables and different development periods. Moreover, we consider the cross-country interaction effect on the employment rate, which fully reflects the mimic management measures among leaders of different countries. Also, some aspects can also be further improved. First, the number of the data of new cases and unemployment rates are unbalanced. Therefore, we didn't consider the impact of coronavirus on the unemployment. Secondly, the parameters are fixed during the prediction. If the training set and coefficient fit can be done in a rolling basis, the prediction can be more precise. Furthermore, the external variables can be explored. That's all for our group's presentation. Thank you.